Let's see. There's that. Can anyone hear me audio-wise? Anyone hear me? Oh, let's see. Bring this around. Can you hear me now? Wonder which. I think it's this mic. Okay. Alrighty. It appears the computer has figured out which microphones to and cameras to look at. Well, it looks like that one's a little bit glary, huh? Not much I can do about that right now, I don't think. Let's see what happens. Not really. No, let's see what happens here. That's just going to mess up the thing. Okay. I'll just get by with the glare a little bit somehow. Let's see. Let me try this light here. Turn off this one here. Come on. Yeah, it looks a little dramatic, but I think it'll work. Okay. Turn this a little more this way. Okay. Anyhow. So, let's see. Anyhow, so here we are. And Eva had her first infusion of monoclonal antibody this morning and didn't have much reaction at the time. But starting about an hour ago, she started feeling a little chilly and this and that. So I think it's hitting her now. Doesn't seem to be in too much distress, but she's pretty well zonked. So that's why I asked Brian to remind me, but like every 15 minutes, you know how I am when I start to get talking, but to go over there and check on her. Her color looks good. She's breathing regularly. She just looks like she's sleeping deeply at the moment. I tried to gently wake her up and ask her if she could set up the live stream. And she's like, could you try and do it the old way? So here we are. Anyhow, as to what's happened the last week. Yeah, this one, it reduces the chance of a recurrence. It doesn't, it's not a normal chemotherapy, or at least what you think of as a normal chemotherapy. It's not a toxin. The idea is it enhances your immune system reaction to proteins that are theoretically on the particular squamous cell carcinoma cells. And hi, Asakura. And as such, it's helpful. She's convinced she needs to do more than just radiation here, but it's hard to tell what to do. So we shall see. My personal thought is they're making such. Hello, Patriot. Jim's not here right now, Patriot. I haven't seen him in a while. He's off doing whatever he's doing. But so my personal feeling is if there is another recurrence in a couple, 3 years, they'll probably be a lot better. They'll have much better methods of dealing with these things. I don't know. We thought we were over it, but it came back. And after 4 years, it shouldn't have come back, basically. It's rare. And it came back pretty vigorously. It was growing pretty fast and stuff. So it looks like, they couldn't find any indications that it was spreading the lymph nodes or anything like that. Unfortunately, the base of the tumor was in the jawbone. And so they scraped what they could, but sort of like removing her jawbone, there's limitations. So is she fasting any? She might soon. Right now she's not, because the radiation in this area here is going to affect a lot of structures in that area. It's going to affect her taste. It's going to affect her ability to swallow. Thank you, Patriot. It's going to affect a number of things. It is expected she's going to lose weight, just because it's going to be very difficult for her to consume enough calories with the unavoidable side effects of the radiation. So she was deliberately putting on some weight ahead of time in order to cushion this. So she's probably going to be doing, a lot less eating, starting in approximately 3 weeks. The radiation starts a week from today. And they say it generally takes a couple weeks before the cumulative radiation dose really starts causing substantial side effects. They'll be doing it for, I believe it's 6 weeks, but she's going to have radiation burns, basically from her skin to her mucous membrane. So I say that's going to cause a lot of issues that will, according to the experts, pretty much give her some weight loss here. She's ready for it. She's not a happy camper, but yes, it is scary. She's seems to be holding together pretty well. And we've got, a lot of contingency plans in terms of what can work. She's pretty much going to be forced to be drinking her food for the next few months, because kind of imagine, if you took a swig of really hot coffee and just burned all of your mucous membranes, how much fun it would be to eat. And that's basically kind of what she's going to be dealing with. They've got some topical anesthetics. Thank you, Asakura. And she's, gonna deal with it. We'll see. Yeah, thin broth. She's got a lot of protein shakes. She's very knowledgeable about her diet. She keeps close eye on everything, and she counts her calories religiously. Everything. So she's going to be going low carbohydrate, um, try and keep the protein up, keep the electrolytes up, and everything else in proper balance. And we'll see how it goes. It's um, not going to be fun. We're guaranteed that. As to how unfun it is, we shall see. We shall deal with it as it happens. Um, so, um, just letting you know what the situation is there. And check her in another couple minutes. I just need to keep a close eye on her. There's no indications right now she's in any kind of distress, just sleeping really soundly. Matter of fact, I hear her making noise. How you doing, little one? Are you okay? Okay. If you're too hot, take off your little comfy thingy. Okay, so uh, she's conscious and coherent and everything right now. She's too hot, so she's taking off some of the things that she was wearing because she was feeling too cold. Yep. Thank you, Brian. So anyhow, thank you, Jimmy. We're just doing the best we can. Jimmy wishes you the best. Asakura, all the people are sending their positive thoughts and everything. And she says thank you, folks. When it comes to the gold mining and stuff, do you want me to get the electrolytic cell so you folks can move it around? You can take a look at it. The design, it actually came out pretty well. To cut the grooves in the plastic, okay, I had to use a router attachment for a Dremel tool. Let me go get it here. Would work great there. Only if you can make it strong enough. A lot of times 3D printing is fairly fragile. Anyhow, here's the electrolytic cell. What it is, this is half-inch high-density polyethylene. Think cutting board, but with smooth surfaces. And so I went and grooved it. I used a guide on the router. Let's see, let me pull this out of here. Okay. Yeah, I'm making a little mess. That's okay. Anyhow, these electrodes, oops, wrong way. These are carbon electrodes here, but they will fit in fine. These are the stainless steel electrodes, and plan. Let's see if I can shine a light through the thing. So you can actually see the internal structure. Oh, yeah, you can. See? The anodes don't go all the way to the bottom. The cathodes do. So the solution, it enters here, and it goes down below the anode, comes up, goes over the top of the cathode, back down over that. So you're getting both sides of this cathode, you got fluid flow, and then it comes out here. Now, the reason these are cut like this is to get that serpentine flow. These actually sit on the bottom of the chamber, and it's not sealed, but it's a fairly tight and smooth fit. So the solution flow, the easiest way is just to come up and continue over the top. Now, somehow I managed to lose 2 stainless steel plates, 2 inches wide, 1/4 inch thick, and 12 inches long. Don't ask me how I managed to do that. Thank you, Jeff. And so there's supposed to be one here too. So you'd have 3 cathodes, 2 anodes, lots of surface area. The solution goes in here, a little peristaltic pump delivers it right there, winds its way through, and then comes out that elbow there, which goes to this downspout. And my desk is getting covered with crap here. Okay. So anyhow, that's basically how it works. And it's these parts are glued and screwed so that it's, pretty much watertight. And these anodes, you can disconnect them individually, pull it out, and then put it in a glass casserole dish, basically, scrub it, put it back in, and like that. Once you got everything taken out of here, then you can clean out this chamber too. You will get a lot of precipitates on the bottom. And so what I'm dealing with here, I don't know if you can you read that? Kind of hard to. What was it, 200 grams thiourea? Yeah, that's basically in a gallon of water. You put 200 grams of thiourea, and no, that's 400 grams thiourea, 200 cc's of sulfuric acid, concentrated sulfuric acid. A lot more if it's battery acid, about 2.5 times as much. I like dealing with battery acid because it's safer. This, in previous usage, we found that the rate of extraction goes up down to about a pH of 1. If you're dealing with, say, a pH of 1.5, you're not getting near the stripping that you do at a pH of 1. Same with the temperature. At about 45 degrees centigrade, call it 120, 125 Fahrenheit. It starts stripping, but then you crank it up to 60 degrees centigrade, which is 140 Fahrenheit, and it cranks out the gold. I also have the little copper strips, and I can just hang them between, things right here. I was doing some testing the other day where I would hang one in the inlet and one in the outlet side to see the amount of gold. So it has a return flow discharge tube. Yeah, I want to get this overflow down to the resin again, because in order to suck it up, these are pretty small tubes. This is pretty small diameter tube. And this little fitting is a really small hole. I don't know what size, 1 millimeter? Something like that. Really plugs up easily. So you have to have an inlet screen. And these just showed up today. I haven't got it installed yet. And the stirring seems to work really well. Okay. I'm pretty confident that the temperature is pretty constant throughout it. And it's just, it sits on a hot plate with a magnetic stirrer. This one here, I was using a 5-liter beaker, but it's big enough it can fit in a 10-liter beaker. With the 10-liter beaker, you'd probably have to go like an 800-watt hot plate. This 500-watt hot plate I'm using, it'll keep it up there at the 140 degrees, but it takes a little bit to get it up there. And so I'm thinking if you wanted to go with a 10-liter so that you could do like a kilogram of resin at once, you probably want an 800-watt heater instead of a 500. 500 might work, but I always like to run things well below their maximum capacity. They seem to last longer. So let's say there's this inlet here that goes to the pump, and then the outlet of the pump goes through a little hole right here. The hose just goes right there and feeds this, and it seems to work pretty well. I was very pleased with how easily it worked. The resin itself that I was using didn't seem to be too heavily loaded, which was unfortunate, but oh well. It was one of the scavenger cartridges. And I'm not sure, little one, but what we might not, in the long run, wind up just letting the solution go back and only using like 1 or 2 recovery cartridges so the resin doesn't get contaminated with base metals. You know, so that by the time you move that cartridge forward in sequence to where you're now getting into the gold, you may have a lot of your bonding sites completely blocked already. So that is one of those things. Now, one thing I have noticed with this, these are carbon anodes. Carbon anodes have a couple of benefits. First of all, do not use stainless steel. Okay? The stainless steel has certain elements in it like nickel, chromium, I'm not sure what. But they'll plate with the gold. They'll come off of the stainless, plate onto your cathodes, and once they're in the gold, they're very, very difficult to separate. So just forget that business. Okay? We used, these are just steel. These are just standard mild steel.
I'm getting a rat sod.
Okay. And they're sacrificial, and they will dissolve over time, but the contaminant is iron, which is really easy to separate from the gold. So that's why we use them. With the carbon, it appears to me that I'm having to put a lot more voltage in order to get the amperage in the cell. And these plates here are no further apart than the ones in our last cell. So it shouldn't be the resistance of the liquid. It should be some other factor, either how much dissolved ions there are in the liquid or these carbon anodes. Because these are going to dissolve, I presume that takes current to do. And so the difference may just be these are dissolving and therefore you're taking electricity. These are not, and therefore you get a lot less amperage. I know that the amount of gold I recovered was pretty modest, and the amount of gold left in the resin was really modest. Okay. I mean, I'm pretty happy with the recovery using the acethiurea solution on our loaded resin from the mill. Okay, that's the max water resin. Yeah, as I say, these are graphite electrodes, and they're supposed to be, reasonably good. But yeah, they're going to have higher resistance, I'm pretty sure, than steel. So I'm not sure exactly what's going on, but I got a pair of steel ones, so I can just swap them out in the exact same solution and see what happens. But this, see if you, that's not really doing much. There you go. Anyhow, you can see there's good. Let's see where we're at here. This one. Yeah, you can see that gap at the bottom of that electrode there. So that's basically how it's designed. The high density polyethylene seems to handle the heat just fine. No problem, no distortion, no issues. These 2-inch wide straps and plates in the grooves seems to work just fine. Seems to do just very well. And all in all, I'm pretty happy with it. I had to increase the size of this elbow right here to get good flow. And need to make sure you have a screen on this or it'll plug. It creates a lot of sludge, one of which is, if you'll notice, there's a blue color. That is apparently Prussian blue, ferric ferrocyanide. But anyhow, seems to work pretty well. Now, let me go ahead and put this somewhere and clean up my hands. And my desk. One of the problems with this system is you're using sulfuric acid. And sulfuric acid has a few issues. Not the least of which is it's a little bit harsh on things. So we need to kind of keep the residues to a minimum. Let me wash this up here real quick. Yeah. See the color? I don't know if you can see that too well. It doesn't show it well on my monitor. But I say the sulfuric acid has some negatives, but it's not horrible. Now, I do not like using the concentrated sulfuric as compared with battery acid. I've cleaned enough stuff, battery acid off me to know it's not going to hurt me too bad too fast. The other issue, this concentrated sulfuric that I'm using is Liquid Lightning from Walmart. And it's 93% sulfuric. It has a red dye in it. Never tried lead conductors. Would aqua regia remove gold from resin? Got a funny story of that. We tried that years ago. It was a reasonable thing. You notice you came up with the exact same thought. And we wound up with a runaway reaction. Luckily, spotted the increase in reaction activity in time and managed to get it outside before life got completely out of control. And so that was a perfectly legitimate thought. It didn't seem to work very controllably. But say this acid thiourea solution, it's pretty easy to handle. It's basically about twice as acidic as vinegar, which isn't horrible. Now, for those of you who watched my video, you may have noticed that the pH meter went wacko on me. Not sure why. Giving me weird numbers and stuff. So I was using pH paper as a backup. But the pH paper does not give me the resolution I need to dial in the actual pH. Now, here's another thing. As the temperature goes up, the pH goes down. Now, it probably works the other way if you're in a basic environment. It probably goes up with increasing temperature. I think just getting more dissociation of the ionic solids there or liquids. But as I recall, if we started out at room temperature with a pH of about 1.65, and I'm in the ballpark at least, but at 1.65, by the time you got it up to the 140 Fahrenheit, 60 degrees centigrade, it had gone down to a pH of 1. The pH is not constant over temperature. So I'll be aware of that. We want it at a pH of 1 at a temperature of 60 degrees centigrade, 140 Fahrenheit. That's the target. The stripping solution also consumes thiourea, it appears to be. In the previous testing, it seemed like for every kilogram of resin, we consumed about 300 grams of thiourea. So there's a certain replenishment you have to do to keep the activity up. And it also consumes sulfuric acid. I don't know if that's from just volatilization or some other consumption mechanism. So anyhow, this particular solution has worked well for us in the past. Currently, I'm running a test right now. I tried using Eco Goldex, has a resin that they say works. And they have a stripping solution that they say works with their resin. Hard to tell without testing. I took the stripping solution that they recommended and went and tried it on the loaded resin from our mill, the Max Water 104133 resin, and it didn't do very well at all. It really didn't strip much off of the resin. And that's not surprising. Makes sense, Gene. Could also increase the ionization of the sulfuric acid too. Yeah, I'm not sure, but it definitely works. But the Eco Goldex strip solution is a mildly alkaline pH of 11 solution of Eco Goldex, not huge concentrations, 20 grams per liter, as opposed to thiourea, which I believe is 50 or 100. I think it's 100 grams per liter. So it would be nice if it would work, but it didn't work on the Max Water. The problem with testing it on the Eco Goldex solution is you need to have some loaded Eco Goldex solution. In the lab right now, what I did was several days ago, I put Eco Goldex resin, which by the way needs sodium hydroxide pretreatment. I pre-treated it, and I put 4 jars, 1 liter each of solution, and 4 grams of resin each. Okay. I ran that for, I don't know, 1 or 2 days. I think it was 2 days. I wasn't in a big hurry. Took solution samples before and after. Haven't gotten the after back yet. But the idea is I needed to load some Eco Goldex resin, so I had some that was loaded. Then I took it and divided it into 3 aliquots, 3 portions. One I stripped using the Eco Goldex recommendations. Another one I stripped using the acethiourea system that I'm familiar with, and the other one is just there as a reference. I'm going to tomorrow theoretically fire assay all 3 of those resins and see what did we start with and what did we end up with depending upon the 2 different solutions. Also, samples of those solutions have been sent off to the lab to give me some numbers there too. You know, those stripping solutions, in theory, should have a fair amount of gold in them. We went from the amount in, well, actually it should be only about 45, 50 parts per million, because that's what I started with. Yeah, it should be 45, 50 parts per million, assuming it's stripped efficiently. So we shall see what we shall see. But I'm testing that right now. What else have we got? Oh, another test I did. The plan is at this point in time to use a resin in pulp recovery after agitated leaching. Now, one of the issues with resin in pulp is the resin grinds down. It breaks down. Mechanical forces act upon it, and it can break up, grind down, abrade, etc. This combined process is called attrition. Okay. And so I wanted to test how much attrition with each rig, because we have two possible options here that we know of: the Eco Goldex resin, the Max Water resin. Which one gathers the gold better? Which one gives up the gold better? And which one stays in one piece better? Because if you put in a kilogram of resin that is screened to say 30 mesh plus, and then you run your slurry after your resin and pulp process over a 60 mesh screen and only get half of it back, the rest is broken up into such small pieces that you're never going to get it back, and you're never going to get the gold back. Attrition losses are serious in terms of it's gone forever. Another issue with attrition losses, if you were to take, let's say you had high grade and low grade, and the high grade you did an agitation tank leach and then a resin and pulp recovery, and you had attrition. If you then mix those tailings with like a heap leach or something like that, that resin, those little microscopic pieces of resin and stuff, they're going to load up with gold to the max over time, and it's going to be gone forever. So if you're using resin and pulp, you definitely want to segregate those tailings from other process, or process flows. With the Max Water resin, I measured a 17% attrition loss. With the Eco Goldex resin, 17% attrition loss. Max Water, about a 9% attrition loss. How you doing, little one?
I'm not sure.
She's not sure. Nothing dangerous though, right?
No.
Okay, let me know. Thank you, Brian. So, anyhow, that's a significant difference between the two. If all else was equal, just that on its own would make a difference. The Eco Goldex resin also had a larger average particle size than the Max Water. The Max Water seems to be harder. So it's my thought that if we took the Max Water and say screened it to 30 mesh, okay, which gives right away about 10 or 15% undersize. Okay, you screen it to like 30 mesh, save that undersize to put in cartridges. It's smaller, it's got more surface area. It's fine for cartridges. And then after the resin and pulp, you go ahead and use a much finer screen. Theoretically, all of the ore should be 100 mesh minus, because that's the output screen on the ball mill. So if you had, say, an 80 mesh screen, then you should gather more particles that have been attritted some, but not just completely obliterated. Now, another thing one could do to minimize attrition losses would be to use less agitation if possible. For example, let's suppose you're doing this process in a cement mixer, an electric cement mixer, okay? And your dissolution portion, you don't have any resin in at that point. Let's suppose you run it for 24 hours, agitation tank leach, basically in your cement mixer, 100%. When it's time to get the gold out of solution, you could put your resin in there and maybe only agitate it 10 minutes out of every hour, say 5 minutes every 30 minutes. Okay. To minimize the grinding and the physical attack on those resin beads. And then again, if you were able to successfully regenerate them, again, screen them again to a coarser size to give you a bit of cushion. So there's various methods you can use to minimize attrition. First, one way that really minimizes attrition is you dewater the resin and just run it through columns. Then your attrition is essentially zero. So there's a variety of methods, and you could even theoretically dewater your resin, run that through a column, and then your dewatered resin, which still has probably a third of the gold in it still, you could add barren solution and resin to that, and then do it. I say there's various strategies you can do to minimize attrition losses. The simplest one is to simply don't do resin and pulp. If you had a pad that you were already using, you could dump your slurry out on the pad, just let it percolate through, and then run it through a column. Stuff like that. Resin and pulp has certain issues. It's pretty efficient in terms of getting contact with the solution, etc. But you've got those attrition losses. So it's a balancing act. If all you're doing is tank leaching, it can make it a lot easier to avoid that solid liquid separation, that critical solid liquid separation. Once you've got the gold out of your liquid, if you lose a little liquid in your tailings, no big deal. You're not losing gold. But if you lose 20% liquid or 20% of your resin, either way, you're going to lose 20% of your gold. So, right now, we want something quick and efficient and, to a certain extent, impressive. It's like, wow, I never thought of that. Sort of impressive. For those of you who saw the video, you can see it looks kind of high-tech-ish, which is good. It's a good marketing stratagem. So that's a good thing. But that's the basic plan at the moment. I'm also doing currently, I can hear the bottle rolls running. I'm also doing confirmation rolls on certain stuff. You've done ion exchange with tanks in series, yeah, not fluidized beds. Well, if you had, I'm trying to think of that, a non-fluidized bed, where basically the resin is just kind of packed, that has certain advantages. There's a variety of things, and again, they're usually situationally dependent. If you've got real low concentrations, fluidized bed might be the best. Packed bed columns might be best if you got real high, well, not real high, but a high concentration, because the very first resin that's getting exposed is getting exposed to the highest concentration stuff. And so you've almost got a countercurrent system going on there, which is going to tend to get you a higher loading density. Whereas with a fluidized bed, you're going to tend to get a better scavenging system out of it. But then you're going to get those multiple columns to do the countercurrent part. But yeah, I say it's all variable on so many things. And I'm not sure. I don't recall. I think I said last Monday, but I'm pretty confident that the fire assay techniques I got are working pretty well now. Yeah, exactly, Gene. Yeah, you use a series of tanks and you run them in such a way that the oldest tanks are the ones that get hit with the newest solution, and the newer tanks are the scavenging tanks. Yep, exactly like I do with little columns. Same principle, counter current. You move the resin this way while the solution flows that way. But anyhow, I did a number of tests, including some with where I loaded resin from solution, where I checked the solution concentrations too. I would go the oldest tanks, the strongest solution, Gene. You know, I'd put them at the new, because that'll load them to the max, whereas the youngest tanks, the ones with the freshest resin, are the ones trying to scavenge out of the tailings. But that's the way I've done it before. But anyhow, I did a number of tests with fire assaying the resin, and it appears by far the biggest source of potential losses is the drying process, at least with the Max Water 104, 133 and the stuff we load at the mill from the Eco Goldex. I can't say for sure of any other system, but that system, clearly the drying was the one that lost the most gold. Taking it and putting it in an oven at like 350 degrees to dry it would lose half the gold. Even at 140 degrees, you lost, what was it, 30%? Something like that. Should have it right here. Our assaying resin. At 140 degrees, we lost 44%. At 250 degrees, we lost 60%. At 400 degrees, we lost 57%. Call it the same as 60. The precision with which I'm doing things is not that good. But I mean, even at 140 degrees, drying temperature, you're losing a lot of gold. Dry at room temperature. Might work best to just freeze dry it if you have that capability. Yep, it vaporizes. You know, those complexes are a lot more volatile than you'd think they would be. So that's the biggest source of losses. The next biggest source of losses was during the ashing process, during the point where the polymer of the beads tends to start smoking, igniting, things like that. That can lose you some gold too, but not that much. 10, 12%, somewhere in there. Not nearly as bad as you'd think. Yes, when they do this stuff in a industrial type setting, they do have scrubbers on the furnaces. Yep, it can be either water scrubbers or activated carbon. I've heard of both being used. Never done it myself. But anyhow, and then the final stage where you're getting the carbon lattices left over from the ashing, quasi-ashing of the resin to get those burned. That looks like you could lose maybe up to 10% of the gold in that part. Now, with the particular flux recipe we were using, which was given on the video, the losses were so minimal in that stage, it's best to just cook it thoroughly, because otherwise that that flux tends to get sticky and nasty and not work real well, etc. So cook that resin good would be my suggestion. Test first. But yeah, because we started out with basically taking wet resin, mixing it with flux, and smelting it down. Okay, with the idea that the uh, litharge would provide the oxygen, and it's time consuming and a pain in the ass. I say that flux did not like that. But if you cook it pretty good at 600 degrees, it seems to smelt pretty well. Um, but dry it at room temperature. If you're kind of radical and cooking it, you know, taking it through that fire and smoke stage quickly and just letting her rip and cooking it for quite a while, you might lose 20-25%. Not horrible if you're doing it for an analytical purpose, but not great if you're doing it for a recovery purpose. Okay. The stripping circuit seems to be achieving greater than 90% recovery. And then theoretically, you could ash and smelt the remaining resin to get the majority of the remainder in there. So I'd say that might work. Now, if you can successfully regenerate the resin, so much the better. So far, we haven't been able to pull that off with the 104133, but theoretically, there's a way to do it. We just haven't been able to figure it out yet. The max water resin says it can be regenerated 8 or 9 times, but I haven't even proven you can strip it once. So we'll see what happens. I do not trust any manufacturer's claims that I haven't proven myself on my particular ore. Okay. Nature has all kinds of weird things it can throw at you. Plus, sometimes manufacturers, especially salespeople, are not the most knowledgeable. And they can misinform you honestly. They think they're telling you the truth, but it's not correct. So always test everything. That's what I'm doing right here. So say that's what's going on. I say I'm still doing tests on dissolution. Leaning towards the hydrogen peroxide pre-treat as opposed to roasting or the OxyClean. How you doing, little one?
Okay.
She's doing okay. Thank you, Brian. So, say the hydrogen peroxide seems to be working just fine. Doing more testing with different samples and stuff to get a better idea how accurate the initial results were. But currently, I think the idea of taking the sulfide cons, throwing them in the little ball mill with hydrogen peroxide, running them long enough to grind the bejesus out of them down to like 200 mesh minus, and taking them out after an hour or two of reworking, removing the slurry from the balls and everything, throwing it into a cement mixer, running it for 24 hours, continuous agitation, and then the next 24 to 48 hours, an intermittent agitation with resin. I suspect it'll work pretty well. Okay. We'll find out. Nothing is ever as simple as you'd like it to be. But that's what's up right now. And also, always make sure you've got either a spare meter or spare pH paper, so that when your meter goes wacko on you, you just automatically double check. I added sulfuric acid several times to that and going, man, it's like this is buffered or something. I wonder what's going on. Well, the meter was broke. That's what was going on. It appears to be so, wage slave, especially in the recovery fraction. When I roasted the material, it consumed substantially more Eco Goldex. It got better recovery, but it used more Eco Goldex. I seem to get similar recoveries by using hydrogen peroxide first and then using Eco Goldex. We're using very large quantities of Eco Goldex. Again, I'm still suspicious there's something in there besides, what I know that really accelerates things. And if we could just find out what that was, we could add some more of that. But I mean, right now we're using Eco Goldex like the weight of Eco Goldex is 10% the weight of the rock to be processed, and that's a lot of Eco Goldex. One of the problems with hydrochloric acid and Eco Goldex is you destroy the Eco Goldex and you create hydrogen cyanide gas. So if you're going to use hydrochloric acid, you'd want to neutralize that first if you were going to be, pre-treating and then using Eco Goldex. The hydrogen peroxide itself is a little bit acidic. I mean, we're getting down there like a pH of 6 or something like that. So I add just a smidge of lime. We haven't seen any tellurium in this stuff. We did a multi-element analysis, didn't see any significant quantities. It was pretty clean material, didn't have a lot of arsenic or lead or, the things you look at and go, ew. So that's good. But that's a tentative plan right now. Yeah, I say, as long as you neutralize it after the initial pre-treatment, not a problem. And again, there's a question of, well, if we use a lot of Eco Goldex to get these good results in 24 hours, can we use substantially less and get those good results in 48 hours? A cement mixer is not real expensive to run. Trying to think. What's the Eco Goldex worth? Let's say, just for the sake of it, $10 a pound for Eco Goldex. We're doing 100 pounds of rock at 1/10. We'd be spending $100 in Eco Goldex. A cement truck would be fine if you were doing full size. I think if you're doing all your run of mine. Right now, we're just doing a concentrate. So we're sizing this for 100 pounds a day. 100 pounds a day, cement, backyard cement mixer works just fine as your batch size. If you were going to do an agitation leach, say you had a good high grade ore running half an ounce to the ton, ounce to the ton or something, yeah, a cement mixer is not a bad plan, And so, a cement truck could handle that. There's a variety of different ways of doing it. You can use just a conical bottom tank where you're pumping off the top and putting it into the bottom. There's a variety of ways. There's something called a Pachuca tank. Now, if you're not familiar with an airlift, if you take a pipe and you stick it in liquid, they do this a lot in dredging in lakes and the ocean. And you take this pipe or hose and you inject water at the bottom. That water forms a bunch of bubbles, which goes up and which makes the water column inside the tube substantially less dense than the water outside the tube. This creates a pressure differential and it drives the stuff up. Now, in a Pachuca tank, they do this. They take a conical bottom tank and they have a tube in the middle. They inject water and it sucks the slurry in and blows it out the top. It also adds a lot of oxygen, which in a cyanide leach is highly desirable. Oxygen is critical to making things dissolve. So the Pachuca tank not only agitates everything, it agitates it violently, which breaks down the Nernst layer on the surface of things and drives those chemicals into contact with the ore, and also adds a lot of oxygen with essentially no moving parts in contact with the solution. Okay, all your moving parts are the air compressor. And if you're running an air compressor for your mine, it doesn't take a lot of air to run an airlift. So Pachuca tanks have been used for a long time, as you can tell from the name, in Latin America. But that's another possible way of keeping a lot of slurry liquefied and agitated fairly simply. Okay. But the violence of agitation is definitely not suitable for resin and pulp. For resin and pulp, you want something a lot more gentle, like big impeller type agitators. Like a giant propeller at the bottom of the tank just moving in a continuous, relatively slow motion to keep it stirred gently. Think simmering the soup as opposed to throwing it in your food processor. But resin and pulp has other considerations. Anyone have any questions or anything on this? Say hopefully tonight I'm going to start ashing resins and stuff. It'd be kind of nice I might have some results by midnight. I don't know. We shall see what we shall see. I should definitely have them by tomorrow. I've got some other stuff I got to get done. No, Aqua Regia just, I don't know if it'll get the gold out of the resin, but I'll tell you what, it goes crazy. We use like 10 grams of resin in Aqua Regia. Yeah. Within a short period of time, we were getting it the heck out of the garage before it went crazy. It goes into thermal runaway. If you were to try and use it in any large quantities, you'd have a problem. In terms of on a laboratory scale, be careful. Secondary containment, all that other good stuff. Ice water bath. Yeah, it reacts in some way, at least with the Max Water 104133. I don't know if it's reacting with the resin, if it's reacting with what's in the resin. I don't know. All I know is like, holy crap, get this out of here quick. Luckily it was wintertime in Montana, so we took it outside and just set it in the driveway and let it finish reacting and cool. We put it in secondary containment, hauled it outside, left it there in a safe spot. But yeah, the Aqua Regia, it does something pretty interesting. So, it didn't seem like a good production system, because we were doing a fairly small amount, say like 5 or 10 grams. And we need to process stuff in the order of kilograms. So, yeah, it would just go spazoid. But the sulfuric acid thiourea leach, Should be completely stripped in less than 12 hours, very controllably. Oh. Any other questions? I know the video quality has been a little weird tonight, but I did what I could. Luckily, Eve is feeling better. She was just really zonked out. She just, I wouldn't say passed out, but yeah, she was really zonked out. So I'm glad she's feeling better. Next week, she's going to get another dose of the antibodies and her first dose of radiation. So we shall see what happens over the next few weeks. How do you think ancient Aztecs refined and melted gold? They did it probably mostly with gravity, I would imagine. As a matter of fact, it's almost certainly. I don't recall any of the chemistry now. You know, around the Mediterranean, they use more complex stuff. But, fire assay has been around for 4,000 or 5,000 years, something like that. So, they did gravity separation. Mainly, I think they did placer gold. I don't think they did a whole lot of hard rock gold. Crushing rock is incredibly time consuming. You really need hard metal to do it. Could easily be, honey bunny. The whole mountain may be mined out by now too, though. So, assayers. There's still some good stuff laying around. Yeah, but even that, there's only so much productivity. You got a slave, okay, fine. But you got to feed them, you got to house them, you got to give them medical care. They're livestock, It's like oxen or whatever like that. I mean, they're useful, but there's only so much you can do. And let's say, so I don't know. The tools you're mining with too, like things like chisels and stuff, how hard were they? Yeah, she's doing fine right now. Brian, thank you. Well, yeah, they had to. Now, you see, that worked them to death thing. That's counterproductive from an economic standpoint. Would you work your oxen to death, or would you keep them reasonably healthy and run them at the maximum continuous output? And you can certainly use up slaves like that, but by the time you get them trained and stuff, it's not terribly efficient. If it's something that you can train them to do fairly quickly and cheaply, and you have an endless supply, that may be. But even then, I mean, would you like to be replacing your entire workforce every 6 months? Well, an ox is a slave. It's an animal, but nevertheless, it does what you tell it to do. It's a piece of farm equipment. A slave in a mine would be a piece of mining equipment. Now, if your primary purpose of the mine was to punish people and get rid of them, like, say, the gulag or something like that, different situation. Yeah, human lives were never worthless. Okay. Sometimes they wanted to kill them because they were annoying, a potential problem, a potential danger. But you don't, you don't take a skilled or even semi-skilled slave and just throw them away for no good reason. Okay. There may be certain situations where you couldn't feed them enough or what, but as a general rule, you give them enough food, reasonable housing, and I don't mean necessarily nice, but I mean it's the sort of thing where they're not going to. It's not a big health hazard, okay? Because you just keep your. I mean, look at what they do to cattle that they're raising just to butcher. Certainly, they don't care about how well they treat the cattle from the point of view of how nice you are, but efficiency, yeah. Again, it all depends on where you were at. And a lot of times, again, the purpose of the slavery thing was to get rid of them. Other times, is use them. I have yet to run into a businessman who's successful who thinks inefficiency is the way to go. I've yet to see a farmer that's successful routinely mistreat his livestock because it's just counterproductive. It's easy to see it's counterproductive. It's just like, if you watch cowboy movies, they're always galloping on the horses. No, that's not how it worked in real life. You don't gallop a horse very long. Pretty soon, you don't have a horse. And as I say, take a look at, let's say, a galley slave, one of the most, slave things there is. Nevertheless, if you've got a galley slave that's moving your warship, you don't want weak galley slaves. You want strong ones. You don't want uncoordinated motions of the oars because you wind up dying. You want people who can do the job pretty darn well. And certainly you're not going to put up with guff. You're going to make examples and things like that. But the purpose in most cases is not to kill them. It's easier to slit their throat. It takes a whole lot less food, And, inefficiency brings its own rewards. If you have one society that's inefficient and another society that's efficient, guess who wins? I mean, you take a look at who were those? The Huns, right? Yeah, they were brutal. Absolutely. You give them shit, they will kill all of you and stack the heads into big pyramids. On the other hand, if you went along with the plan, it's okay. You can live. Say it's just a matter of what's the easiest thing to do and what bang for the buck. Let's see. You got. Yeah, you want to talk to Rock Butcher's wife about that. She's from Mongolia. But yeah, again, any society that is routinely horribly inefficient usually doesn't last too long. Some more efficient society comes along and overwhelms them. Any other questions or anything? Subjects to bring up? So, I'm continuing to confirm stuff, refine the knowledge, verify stuff. I mean, the boys are spending a lot of money on solution assays. Trust me. I'm running a bunch of tests, and each one costs them about $30 in a solution assay. It adds up quick. I took this morning 9 or 10 just from this weekend. It adds up quick, but that's how you find out what's going on. And in some cases, I say, now that I got a fair amount of confidence in the solution assay to give me reasonable results, not highly precise, but reasonable results. That's good. Still, I haven't really done much in the way of spot tests lately. It's been too unreliable. I should probably start working on that. See what I can come up with. Anyhow, any other subjects or anything? Any questions? Any ideas? Oh, last week somebody suggested taking the resin and putting it in acetone. Now, I didn't try it with the Eco Gold X resin, but I did try it with the Max Water resin. And here we have, this was a week later in acetone, virtually no detectable change. So that one didn't work. It was a nice test though. Yeah, the Max Water sure doesn't dissolve. Since I didn't have any loaded, what do you call it? EGX resin. Didn't see much reason to even try it. But yeah, you can see the individual beads are still there. They're not sticking to each other like you'd expect if the surface was starting to dissolve, anything like that. So anyhow, it's an interesting experiment, easy enough to do. Oh, well, I think we've pretty well talked everything out there. But that's the status of the research at this time. And oh yeah, regular styrene would just disintegrate instantly. And I say there's cross-linking or something. I think go ahead, honey bunny. I need to pay some attention to Eva here. And like that. So if nobody's got anything else, let's go ahead and call it a night. Yep. Yeah, it is not normal styrene, that's for sure. Yep. So anyhow, we'll go ahead and call it a night tonight. If anyone has any questions or whatever during the week, write them down so that we can address them. So until next week, happy prospecting and keep it safe out there. Let's see. Trying to remember how to do this. In stream. In.